eles só vão abrir quando der 12 horas aqui, exatamente.
São Paulo. Cadê o homem? Cadê uma placa pra gente escrever? Não. Será que dá pra eles enxergar? É, porque no caso teria que ser conectando, né? Então, dá, já acabou de fazer. Verdade. Tem uma atriz, se você quiser, eu vou pegar.
Tá, então vou trazer aqui detalhes.
Nossa, eu não tô oferecendo.
Que parece que a sala tem que
Best part of your job. Isso. Porque a gente já sabe que ele trabalha no CERN. E o working é trabalhando. Isso aí. trabalho junto.
Hello? Can you hear us? Yes? Okay.
And you guys know how to mute your microphone too? Yes. Okay. Well, I hope everyone's had a great master class so far. I guess we should probably introduce ourselves. So I'm Michael Plano. I'm a graduate student working with the University of, well, we say Notre Dame. It's an American university that's not really affiliated with France, but we sort of stole your guys' name. And I work at the LHC on CMS, looking at, hey!
You need to turn the camera, I think.
Que medo dele.
They can't
Yo
hear.
no quiero. Hello. Madrid has some technical issues and we are still waiting for Hungary.
Right. Okay. Yes. So I've been at CERN for a couple of years now. It's pretty exciting, and I do some work on hardware and some work on software, and then analysis, looking for cases like you guys may or may not have done today. We can have more questions and things like that later if you guys are interested in anything else. But now, Ria.
So, yes. Okay, we have a bit of a camera problem here. Okay, so my name is Maria, and I did the IR postdoc now with the University of Wisconsin in the US, obviously. I did my thesis I am working for CMS, like Michael, and I did my thesis in Madrid in the institute that I think cannot hear me now, which is CMS. I think they will later. So, well, essentially in CMS, my work is part of it. I work for the trigger. The trigger is a very important part of the experiment. And I also look for fixes, for strange fixes. Okay. So that's me. So now we want to hear a little bit about how your day went today. Okay? So let's start with Perugia. Hello, I am Perugia.
Hi, hello.
Hello. I was in Perugia a few years ago, and it's a really beautiful city, so I really enjoyed it. How was your day? How is it in Perugia today?
Excuse me?
How was your day?
It was a good day. We have in the morning a lesson about all the large hadron collider, the quantum form, and something like this. And then we do some experience of simulation at computer.
Okay, so you have fun.
Yeah.
No. All right. Yeah. So that's awesome. Why don't we swing on over to Brazil right now? So. I was born in North America, but and I've never been to South America. If I were to come to Brazil and I got hungry,
Sorry, if you are hungry. Hello?
hi.
Hi. So what you were saying about Brazil, South America?
I would like to know what the best thing to eat is in Brazil.
The best thing to eat? She knows very well. Barbecue. Feijoada, rice and beans.
I thought that America did that pretty well, but I'll have to try it out in Brazil and see how it compares. Thanks, guys.
Okay, can you hear us now?
Eles querem ouvir feijoada, na verdade.
I don't know if Madrid, we can see you now, Madrid, but I don't know if you can hear us or not.
Yeah, Madrid, if you can hear, can you guys wave your arms in the air or something? Or yell?
I don't think they can. Hola! Okay, so let's skip Madrid for now and let's go to Lyon. Okay, so you are the guy that is closest to No? Lyon is very close to Geneva.
Yeah.
So, tell us something about Lyon. What is it that you like most about Lyon?
We can't hear you. We have issues, we can't hear you.
Okay, so can you hear me now?
A little bit.
Oh, I cannot shout much louder. So, what is it? You're from Lyon. Lyon is close to Geneva. What is the thing that we should visit in Lyon if we go to Lyon?
Oh, the old lion. There are a lot of churches, and what? There's a good restaurant. There are good restaurants because. And the old city you can visit.
It's very beautiful.
It's beautiful.
So we should all go. So you also have fun today, no? With the exercises.
Can you repeat, please?
I just asked you if you had fun, but I think you did because you were like,
Yeah.
Try Madrid again.
yes. So Madrid, can you wave if you can hear us?
See a microphone.
Hi Maria, can you hear me?
Yes, we can hear us. We can hear you. So can you hear us from there?
Yeah, the problem is that we are having a lot of problems with the Polycom. It worked perfectly yesterday, but today we can't really connect it. So we are connected from the moderator PC here in CMAT. So you see only a fraction of the people in the room, and we can hardly hear you. So it's really silent. But anyway, we will try to proceed. So we have a speaker around. Well, Maria, because we are trying to fix the Polycom, so we are not aware. Are you already reporting from the institutes, or is just the first round?
So we were just saying hi to everybody, so that everybody hears each other and.
So we say hi. Say hi, guys. Hi. Hopefully you got it.
Okay, we did.
Thank you for your patience, huh?
No problem. Okay, so we are actually missing one of the groups that hasn't even connected yet, Hungary, but I think we need to move on, and then if they connect later, they'll join, okay? So we are now going to move to actually seeing your results, your exciting results today, guys.
We want to go to first.
Lyon, for example. Okay. So we need somebody from Lyon to explain to us what you have done today. We are going to be showing your results in a second. You can see them now. Okay, so one of you, tell us what you did today.
We have organized 1,800 events. We've done 331 state candidates, 724 W candidates, and 21 fixed candidates.
We managed to have a near-perfect ratio, W to electron over W to muons of 0.96
and a W plus over W minus ratio of 1.36. We also saw the jet spike.
Okay, so do you understand what all of this means?
Yes.
Yes.
Plus ou moins? More or less.
Okay, so for example, why is the W ratio 1.3? Why is one of them 1 and the other one 1.3?
Because 2 is more difficult.
Good.
Can you say that again?
Maybe you can take two. Maybe. Non, je me demande si on fait une fois que je fais enfin.
Okay, so you're all laughing and having fun, which is important. It's because of how the proton is inside. Okay, that's why it's not the one.
Yeah.
It's because there are more quarks up than quarks down, so that's why we have a ratio of 1.30.
Okay, excellent, fantastic. That's what I wanted to hear. Okay, so that's very good from Leon, and we see all the nice pics in the math histogram, and maybe the next group will comment on the math pics. Thank you. My thesis was on W, so I was very excited to see the W ratio. Okay. Okay, so
Yeah.
your turn.
All right. So let's see. Why don't we try jumping to Perugia?
Hi,
Hi. So let's start. Do you guys want to give us a little overview of how your day went and the numbers that you got out here?
So we found more positive W because since we are colliding with protons, it's more probably to obtain a positive charge. And we also found a ratio of electrons and newtons near to 1. So we can say that they are something the same number.
Okay. All right. And so let's jump over here. So do you guys see this this plot, I guess, that you made? So these are all the numbers, the masses of the particles that you guys found today.
Yeah, in this graph we have a peak around 3 and 90, and some isolated events of exposure.
Okay, so you where are the Higgs bosons?
120.
Okay, so these are Higgs bosons here. The 120. I don't know if you guys can actually see where my mouse is or not. Maybe not. Yeah. Okay. So that's cool. I have a question for you. Why? So you say that there's a particle at 125, but okay, I see you have a whole bunch of events at 55. So why do you decide that you have a new particle at Higgs boson at 125 and not one at 55?
Because we know that the Higgs boson is more heavy.
Yeah, okay, so to be honest, I agree with you that the bump at 125 is definitely a Higgs boson, and the one at 55, okay, probably isn't really anything. But we'll discuss this maybe a little bit more when we combine the total results. But yeah, so I'll leave it as a little bit of a mystery as to why maybe there's not a particle at 55, and we'll see if it gets cleared up as we continue. All right.
Okay, so maybe let's try again Madrid, that now appears twice. Okay. we cannot read it, but okay. Pablo.
So I'll move this to Madrid.
Okay, let's see if we can actually read them here because I am not sure.
Yeah, Madrid, can you say something?
Hi.
Okay.
Puedes mirar ahí si quieres, esa cámara.
Okay, so we have a brave person from Madrid now with camera. So go ahead, tell us what you found today.
Hello, my name is Jorge, and we are here in Madrid where we have done some investigations today. We have examined event collisions with an event display program, and we have done several measurements. And first of all, we have the E-mu ratio, which is 0.9, which is very close to our expectations. Then we have examined too the W plus W minus ratio, protection ratio, and our results are 1.44, which is very close to what we were told to find, because our expectations were like this result. And finally, we have examined the mass spectrums of the electrons and the musons. Our results are 3 great peaks in some particles. For example, in 3 GeV, we have a peak which corresponds to the GeSi meson. Then we have another peak which is in 90 GeV, which corresponds to the Z boson. And finally, we have found a small peak, not as great as the other ones, which is in 125 GeV, which corresponds to the Higgs boson, but our statistics is small to be sure about it. And these are our results. We are here having a very good day, and thank you very much for organizing this event.
Okay.
Very nice.
Very nice report. So, do you want to tell us something about the event display? How was that? How did you find it? What do you see in the event display?
I'm sorry, but we have found nothing.
So how did you decide?
He was kidding.
What is the question?
What is the question we have got?
Yes, so the question was not if you have found something weird, but what is the event display? What did you see in the event display?
We have found Z bosons, JZ boson, mesons, and the Higgs boson.
So when she says the event display, she means the sort of pictures that you guys looked at. So did you see actually, when you were looking at the picture, say the J psi or the Z boson, or did you see something else that you
Yes.
Okay.
Yes, we have seen electrons and musons.
Okay, that's what I was going for.
I think we have a new member that has joined our group.
Yes, so maybe we can all say hi to Hungary. Hungary, can you hear us?
Yes, we can.
Hello, so welcome.
Hi. Yeah, so just a quick I'm Michael, and this is Maria, who maybe you can't see in the
Now you can see me. Hello. Okay, so maybe we can move to Hungary, and you can tell us how your day went, and also we will show your results, and you can comment them.
So I will have Hungary's results on here. And if you can have someone say how your day went, and then tell us a little bit about the numbers. That would be great.
Sorry, but the students don't want to speak.
Okay, well, here, I have a question before we get started. So actually, it should still be winter and I would say ski season in Geneva and the surrounding area, but it's kind of unseasonable, well, maybe not unseasonably warm, but it's very warm here. And after I'm done working, I'm probably going to go just hang out and read a book outside. What's the weather like in Hungary? Will someone answer that question?
Right, it's a beautiful day here too.
Okay.
The sun is shining and it's warm, so something similar.
Okay. Very good. Do you, would someone like to, bring your numbers right now? Would someone just like to something about the email with the W? A little bit about the numbers that you have there on
Taking a closer look. We had, if I see it well, 383 muons, muon events, 445 electron events, of which was 50 W, 221 W minus, 281 W plus, 276 Z, 30 X, 142 Zoo, which is altogether 1,000 events.
Particles. So, I think, let's see. Yeah, okay, I think we covered most of the questions. Here you can see the mass bins, and it looks like you guys have very similar looking plots to the other groups. Maybe a fewer total events, but that's fine. Your group is a little bit smaller, I think. And actually, we're maybe running a little bit short on time, so it might be good to just move to Sao Paulo now. And then we'll combine the results and we can discuss afterwards. Thank you, Hungary.
Hello. Hello. Can you hear me?
From Sao Paulo that wants to tell us what you saw?
Yeah, we had 2,357 events. We had a similar number of electrons and muons, 1.05. We had a little bit more of W plus bosons than W minus, 1.21. And not all the people did all the events. I think more or less half of the people did all the events. And we had a lot of events at 3 GeV of energy. So we had, we discovered around 3, we discovered J psi. And a little bit further at 5 or 7 GeV, we discovered Epsilon. And we had 40 Higgs bosons discovered at 125 GeV or 127. And we had we had discovered Z around 90 GeV. So we discovered 4 Nobel Prizes. So that's it.
They got a Nobel Prizes.
Okay.
Yes. We also should do one, right? So, okay, so do you want us to tell us, was there anything special in what you saw? Anything that you want to remark? Something that you found especially interesting?
Yeah, we have found 4 Nobel Prizes, right? So I think that's very interesting. And that's it.
That's it.
Thanks.
Okay, I think we should move to combining the results, and we'll have a little bit of a discussion of the measurement as well.
Thanks. Okay, so now what we are going to do is put together all the things that you have seen, okay? And you see that now we have, between all of you, between the 5 groups, you have analyzed 6,755 events. That is a lot. So you have done really well today. And you see that the ratio, once we combine all the stats, the charge ratio, the charge asymmetry of the W is again 1.3, okay, like expected. And now if we go to the discovery plot, okay? You can see that the little peaks that we were seeing before, now they are, as you can see, much clearer.
Yeah, so this was the comment that I was sort of making earlier. We saw in, I don't remember, maybe Perugia's data, there was a little bump around 55, which is still sort of there. But when you look at the big peaks here, so the 125 now, I would say it's much more clear when you look that there is something here, and that this point at 55 is just sort of a small fluctuation that probably isn't something. And so this is one of the very important things for particle physics that we deal with quite often is we need to run over a lot of events. And it's useful to have a lot of people all working together to be able to do this.
Yes. And in fact, this that we are doing now, this video conference in which we are all together, it's something that we do here essentially every day. So this is what we do. We all work in different places, and then we just sit together and combine the results together. We discuss it in video conferences, and that is the way to finally get to a discovery, because each one of you have like a little view of the total data set, the total analysis, and only when we combine all of you together, we can really find the Higgs, find the C, see the Xi, etc. So now we were talking a lot, but is anybody from you that wants to say something actually? Do you want to speak up and make comments on the combination of the results?
Yeah, is anyone impressed? I mean, is there anyone out there who feels like combining the data now you can see something more clearly? Did you learn anything from hearing what the other groups had to say?
Do you have questions to the other groups? That is also fine, eh?
Yeah.
So, be shy.
Okay. Let's see. Yeah.
I have a question. Why is there more W positive events than W negative, whereas the original, the most common electron is negative? Why is that?
Yeah, so we, I think, sort of already had discussed this a little bit, but yeah, so at the Large Hadron Collider, we're colliding protons with other protons.
We can make Leon.
Yeah.
We asked this question to Leon before. You can answer to Sao Paulo. Same guy before. The same question is why we have W plus and W minus, and then in normal life we only have electrons, negative electrons.
It's because there are more quarks up than quarks down.
I don't know, Paulo, what are you asking? Why do we have only electrons in normal life? Only negative electrons? What does it?
Sorry.
Because ions are too heavy to exist.
Sorry, why did you ask? I didn't hear it properly.
No, we were asking. So I was asking you what were you really asking. So what was your question? I was trying to rephrase your question. I don't know if you were asking about antimatter actually. That is what I want to understand.
Can you just repeat your question once more?
Our sound isn't very good. Can you speak it slowly, please?
We were just wondering if you could repeat your question once more.
Of course. So, there are more W positive events, and why were there more W positive events?
Yeah, and their answer was well, their answer was that we're colliding protons and protons in the LHC, and the protons are made up of quarks, which basically have more positive charges than negative charges, and so you sort of.
Okay, thank you. Thank you.
So you have more questions. Do you want to ask us anything? It doesn't need to be about today. If it's today, great.
Maria, we'd like to ask a couple of questions from Madrid, if you don't mind.
No, go ahead. Go ahead.
What do you have to do to work at CERN?
Okay, so since I can answer you what I did, I studied, since you're from Madrid, I studied physics in Madrid. I went to the same place that you are now, okay? I got my PhD in PMR to work at CERN, and part of my thesis I was here, okay? And then since I like it so much, I stayed. That you study physics, and you do a PhD in particle physics. That's for working directly in CERN, but even before that, you can do little stays in CERN, I think already as a student.
Yeah.
And as something that is quite cool that I didn't do, is that as a university student, you can come to CERN in summer, that's called summer students, and I think it is great. I regret not having done that.
Yeah, so when you're here, certainly certainly people who are from member states of CERN can come and be summer students. Since I'm originally from America, the United States of America, sorry, I don't think we can be an official part of the official summer student program, but there are still other ways to go there. Usually you should be in university, and then I think that's true for the summer student program. And if you search for CERN summer students on the internet, I think you'll find some information about that. And it's a great program. Since neither of us were in it, we don't know for sure, but the kids who come here look very excited.
Yeah, I think it's a late thing, eh?
Yeah, thank you. We have a second. I have to say I was some student in the age of the dinosaurs. That's a long time ago. We have a second question from another student.
We have a question.
Hello, I'd like to ask, what do you think is going to be the next particle that you're going to discover in the CERN or in the NHD accelerator?
I think it's better if you answer this one, actually.
Okay, I actually don't know, okay, what is going to be the next one. I can tell you for sure that I am trusting that next year we are going to find something exciting. And in fact, if you ask me what I want to see, like if a letter to Santa Claus, okay? So just what I would like to happen is to find something that we are not expecting at all. So then I cannot tell you which particle, because I really want to find something that nobody expects.
Yeah.
See what I mean? That would be like a Christmas present to all of us, I think.
Okay, so it looks like some other schools have
Yeah,
some
here in
questions.
São Paulo we have separated some questions, but you have answered some of them. One of the most interesting I was just once, how much time do you spend searching new elementary particles?
How much time do we spend searching for the particles?
Well, that's an interesting question. It depends on exactly who you are. So in fact, well, I personally have been working on hardware and software for CMS, and so I haven't spent a whole lot of time doing what you would call searching for particles. And actually, specifically, I will be for this next run of the LHC when it turns back on, working on an analysis that studies the Higgs boson, which is a particle we've already found, but we want to know more stuff about it. So I actually won't spend any time looking for new particles. But there are a lot of people here who that's all that they do. They spend all of their time looking for new particles.
No, all of us have to spend some time working to make the experiment happen. It's complicated, no? So we have to all collaborate, and then the big chunk of all of our time really goes into making sure that we can identify muons and electrons correctly, like you were doing. Okay, so we have to decide what is a good electron, what is a bad electron, how to record the events, make sure that the detector is working properly. So all of us have to do some work on that. Okay? Then we also have to spend some time studying particles that already exist, like the Higgs boson now, but like the W and the C. It's very important to prove that we understand them well. Okay, and then we also look for new particles. So we are really busy. We have to do many things.
Okay, thank you.
Did that answer your question?
Yeah, we have some more.
Yes. Okay, go ahead.
What is the best part of your job?
So, I don't know if my answer is a little bit difficult, but I really enjoy working with other people, and I am a postdoc, and part of my job is working with our students, and that is one of the things that I like most, working with the students.
Yeah. So for me, there are two things that I really like doing. So one is when we have a really hard problem, and then I can spend a lot of time trying to solve it and figure out what exactly was going wrong. I think that's fun. It's kind of like a puzzle. You have to find all the pieces and figure out how they fit together. And then the other thing that I really like is just that I get to meet a lot of very different people. You know, growing up in the United States of America, okay, there's some different people there, but I don't meet a whole lot of Europeans, for instance, or Russians, or so on and so forth. So it's very nice to get a bigger world view than I otherwise would have had. And I think maybe you guys have some more questions, but we should move to another school to see if anyone else has some. And if we have time, we can come back to you.
Let's do two questions per school. Okay, so let's move to Leon. In the line. Leon is not prepared.
Tout ça on dit que toute question est posée. All the questions. You have already answer of our question.
Perugia? I'm looking into Perugia. We have somebody in the first plane.
You might still be muted, Perugia.
There's a problem with the microphone here.
Okay, now. So, do you have any question that you want to ask us? Ask us or ask any of the other groups, that also goes. This is...
It was difficult to build a large hadron collider.
To build, is that?
It was difficult to build. It took a lot of years and a lot of effort, and putting together a lot of work from all places in the world. So.
And the Large Hadron Collider, I mean, you can think about this. I mean, they spent a lot of time and a lot of money, and they built it, and then we tried to turn it on the very first time, and then there was a problem, and then it had to get turned off to get fixed for a little while, and then turned back on, a year or two later. And so I think that gives you an idea. Also, when you consider that each experiment has a few thousand people working on it, and everyone has to do their part to keep it up and running, I mean, I think it shows you that it's a tough thing to do.
Okay. And there is a project of building a big one, a bigger one.
People are always proposing that we should build a bigger detector. Certainly, so, before we get too excited, we should wait and see what the next little bit of running of the LHC has to offer us. But either, I would say, if we do find something really exciting, it'll just tell us how much bigger the next accelerator needs to be in order to study it properly. And also, if we don't find anything too interesting, then probably we need to build another big accelerator in order to see, because basically right now we know that there are things missing that we don't understand. And there must be new particles somewhere, and it's just a matter of finding them. So if we don't find them in the LHC, it's going to be a little bit harder, but we need a new accelerator to do it. And yeah, that's pretty exciting. And if any of you guys are interested in something like this, you could try to get involved in one of these other accelerator projects as well and get it on the ground floor. Yeah.
So maybe we can, do you have more questions in Perugia? I think we should move to Hungary. Do you have any questions in Hungary?
Yes, I have one. Do you constantly put in or
Sorry, the sound broke.
Do you have a constantly routine in CERN? Or each
Hold the microphone a little further away, maybe. Very well.
Do you have a consistent daily routine?
We have been, the sound is a little bit, so I don't know if you're asking us if we have been all the time in CERN. We live in CERN, you live in Geneva. Okay, yes. So yes, both of us are based in Geneva. So we work for universities in the States, but we are here all night. I live in the city, even
Yeah, so I live in a small town in France called Poirier, which is a little ways away. It's pretty close though. So it's a more relaxed life than living in downtown Geneva, but
Geneva is
that's true.
yes, so I enjoy living here. So being in CERN is a really an experience. It's very international, like Michael was saying before.
Yeah, and there's a big lake you can go swim in.
It's a nice place. So do you have another question in Hungary?
Yes, no? Anyone? It can be about anything.
No?
Okay.
Okay, so then I think we are going to move to the quiz. Okay? So I think you know that we have a quiz for you, right? It's just for fun. Okay? So there are no wrong answers here, or there is no competition, it is just for fun.
Yeah, and so I don't know
Vou
if you
projetar agora
guys...
o quiz aqui e a gente vai responder. Pode sentar.
So hopefully you can see...
Okay,
So first, can someone tell us that if they can see the quiz right now? Say yes or no?
Yes.
Okay.
Okay, so we are projecting the quiz. So, I think you know the rules of the game. So we have 7 questions. Each one of them has 4 answers to choose. Okay, it's like who wants to be a millionaire? The same idea. So you have to mark your answer on your answer sheet before the time ends. Okay? And then we will tell you what is the correct answer.
Maria, you are projecting the slides with the answers.
Really? Sorry.
Well, pretend you didn't see that.
Yeah, sorry.
Yeah.
Some technical issues from the beginning, maybe? Yeah, we are.
I'm watching at the only answer.
Yeah. Don't go away from that. Let's click on here. Yeah. Yeah, I see the answer to the first one. Yeah, sorry, guys.
Yeah, click on the thing. Okay.
I don't know what time it is now. Yeah, now it is okay. Sorry. Okay, so pretend you didn't see them. So everybody has technical problems. We also did in the end.
Yeah. Every meeting we have, I would say I have technical problems.
Yes. No, sorry. Okay, so well, essentially, just every time that you answer correctly, you go a little bit higher in energy, and of course the goal is just to go to the LHC energy for this year. Okay, and as I said, we don't care about the results, we just want you to have fun. So, let's start.
Okay, so first, which particle is the mediator of the strong force? Is it A, the neutralino, B, the snail, C, the gluon, or D, the pig xenon?
Qual que é a partícula que é a mediadora da interação forte?
You know, okay, it's hopefully an easier one, but you know, it could be a little tricky here. I'm not 100% sure if I know what the answer is. Let's see what it says. Hopefully everyone picked their answer. And it's the gluon.
Okay, so you heard about it this morning, I am sure, okay?
Yeah. Wow, I was just going to say, okay, so that's the particle that, or the particle that holds the quarks together inside the proton and the neutron and things like that.
Okay, so the next one is, what percentage of all the matter and energy in the universe do we know almost nothing about?
Qual porcentagem de matéria e energia do universo que a gente não conhece?
100%? Or is it 32.8%?
13%, 100%, 96% ou 32%?
Like terribly, only a little bit? Maybe we know it all already? No. What is the answer?
Eita, meu Deus. Eduardo, põe lá no...
Okay, we can hear you right now. Okay, so the answer is...
Não é para liberar para eles, eu só estou falando em português aqui.
It doesn't, what we know, what we are made of, is only 4% of all the universe, so that's impressive, eh? So we need you guys, we need to do study physics and have to take the test.
Yeah, and that's one of the things people are hoping we'll see in the LHC is this thing called dark matter, which we know corresponds to something like 25% of the universe that we don't know about. And so there are some people who are looking for dark matter particles in the LHC.
Aqui está incluída a matéria escura e a energia escura também, tá?
70%.
We'll still need them, eh?
Yeah, we will still need you. Okay, so which of the following is an experiment at the LHC? Is it Alice?
Qual dos seguintes experimentos é o experimento do LHC?
So, yeah.
Vocês podem responder no seu questionário. Opal, quem já ouviu falar em Opal, Kate e Fluffy?
Yeah.
Okay, so the answer is Alice. That I have to tell you that I want somebody to invent an experiment that is called Fluffy because I want to work for that. So I hope it is in one of these future things we can put something that is called like that. Totally euphoric. And I think Opal was actually an experiment in that. It's a valid answer, but not for the experiment. Okay, so which two people won the Nobel Prize for Physics in 2013? So, Stephen Hawking and Marie Curie, A. Peter Higgs and Stephen Hawking, C. François Englert and Albert Einstein, C. Or Peter Higgs and François Englert.
Quem ganhou o prêmio Nobel em 2015?
You know names?
A. Stephen Hawking e Marie Curie. B. Peter Higgs e Stephen Hawking. C. François Englert e Albert Einstein. D. Peter Higgs e François Englert.
Very recent, guys. So this is 2013, we are in 2016, so you should remember it. Okay? And of course the answer is the Higgs from UK, François Englert from the
Okay, which of the following technological innovations was invented at CERN? Was it A, the teleporter, B, the World Wide Web, C, 4G mobile phones, or D, sharks with lasers on their heads? Okay, for this one, I don't want to give anything away, but as far as I know, the teleporter only exists in shark communication. Sharks with lasers on their head, I think, were invented many years ago. The World Wide Web. Okay.
Quem acertou essa daí?
You managed to come to CERN and receive an little class where the guy was working, very near my
And you guys probably noticed, but today we have a lot of data that we need to share back and forth. And so that was sort of the original reason for the World Wide Web, was physicists sending each other data so they could find things.
Yeah, making something like this possible, no? And make it happen. Okay, so during a long run where the proton beams might circulate for up to 10 hours, how far will these protons have traveled? If they have no interrupter, of course. A, the distance from CERN to the Sun and back. B, the distance from CERN to the center of Geneva, so what they do every morning. The distance from CERN to Neptune and back. And D, the distance around the circumference of the Earth.
Então a pergunta é, em 10 horas de operação, o feixe do próton está rodando ali. Qual a distância que ele percorre durante essas 10 horas? Uma boa dica é saber qual a velocidade do próton.
As probably you remember that the particles in LHC are moving at nearly the speed of light. So 10 hours, I guess, is about how long it takes to shine.
O próton viaja na velocidade da luz, tá? Então ele percorre em 10 horas, 10 horas luz.
Which elementary particle is most common in your body?
Qual partícula elementar é a mais comum no seu corpo?
Downward. The electron or D, the bottom one. And I think if you guys were paying careful attention to our discussion earlier, you might have a hint at the correct.
Quark up, quark down, electron ou quark bottom.
So we hear a lot of discussion, so maybe you will agree with the upward.
Quem acertou essa daí?
They are made of the most common one in your body. Okay? So, at your energy level, you get to 70 degrees and we will get home to that.
Yeah, we have fun.
Yeah. So, this is the end for us, guys. I hope you have fun with us. And if we have some technical problems with the video. And see you next year. Okay? I want everybody to say goodbye.
Yeah, if you had fun, say goodbye and wave your hand.
Bye, guys.
All right. Thank you.
Sim, eles já saíram ali.
Ah,
Só um resuminho aqui, vocês entenderam as perguntas e respostas? Não. Então, só para perguntas locais aqui, ela perguntou quanto tempo eles passam procurando por novas partículas. Quem entendeu o que ele respondeu? Você? Então, ele basicamente falou que no trabalho dele, diário, né, o que ele faz? Ele basicamente trabalha com hardware e software, ou seja, ele está preocupado com o funcionamento do sistema lá de detecção. Então ele está lá ajustando para que os detectores detetem direitinho os elétrons, os míons, as partículas que a gente detecta, e pouco tempo que ele passa procurando. Na verdade, a análise dele, né, recolher os dados e procurar alguma coisa nova, ele não está preocupado em procurar partículas novas, ele está analisando o bóson de Higgs, que já foi descoberto. Então, ele passa muito parte do tempo para que a gente enxergue direitinho os elétrons e os míons, e uma outra parte do tempo inferindo dos elétrons e dos míons, e dos hadrons também, né? Inferindo propriedades de uma partícula que já foi descoberta, que é o bóson de Higgs. Porque a gente não basta descobrir, a gente tem que saber direitinho o que ele é, qual que quais são todas as propriedades dele. A moça falou que ela já passa algum tempo procurando por alguns tipos de partículas novas, né? O nosso grupo aqui basicamente trabalha procurando novas partículas, procurando novos tipos de fenômenos que a gente observa dos dados. Então a gente utiliza a gente olha os elétrons e os míons e os jatos e tenta ver se tem algum fenômeno estranho ocorrendo que não estaria contido no que a gente esperaria, tá? A outra pergunta como se chama? Da Letícia foi sobre o que ele gosta mais do trabalho dele, o que ela gostava mais do trabalho, né? Quem entendeu? O que ela falou? Bom, ela falou que ela gosta bastante da interação com os estudantes, né? Que ela gosta de trabalhar com os estudantes. Ela é uma postdoc, tá? Então ela está mais ou menos que nem o Ângelo aqui. Você vê que o Ângelo também gosta bastante de trabalhar com vocês aqui. E eles gostam também bastante dessa vida internacional, de conhecer as pessoas de outros lugares, conhecer trabalhar junto com outras pessoas de países diferentes. Além disso, uma coisa também que ele falou que dá prazer para ele é quando ele tem um problema difícil de resolver e passa lá semanas buscando a solução daquela situação, né? Quando você encontra uma forma de resolver o seu problema, uma forma nova de olhar para os dados e tirar dali alguma coisa, isso é uma coisa que deixa ele motivado. E o Ângelo também.
Não, só acrescentando uma coisa aqui que eles falaram que também é importante, vocês tiveram a experiência de analisar dados reais, mas outra experiência que vocês tiveram aqui também é a videoconferência, tá? E para quem entendeu, ela faz parte do nosso dia a dia. Às vezes a gente tem videoconferências durante o dia inteiro, às vezes todos os dias da semana. Por que isso? Para compartilhar os resultados, compartilhar informações, juntar informações e uns ajudarem os outros. Na nossa colaboração CMS, por exemplo, a gente tem mais de 4.000 pessoas e essas pessoas se comunicam entre si o tempo todo para fazer um bom trabalho e para fazer essas descobertas que vocês viram aqui. Então vocês também tiveram essa experiência da videoconferência, tá?
Isso aí. Bom, então é isso, tá? Então deixa eu passar para a Gisele e ela vai fechar aqui o nosso e-mail.
Bom, agora é o momento que a gente quer ouvir um pouco a experiência. No ano passado a gente acabou o evento com uma mesa redonda e esse ano acabar é sempre meio triste, então a gente resolveu fazer algumas atividades com vocês depois. Mas eu queria conversar um pouco antes, porque pra gente é fundamental ouvir. Só vou começar com uma questão. Questionário. Todo mundo respondeu ao questionário? Sim, já entregaram? Não. Então, os monitores, Fernanda e Vitor, vocês podem recolher? Por favor. Esses questionários eles são fundamentais para a gente analisar o evento e para fazer mudanças no próximo ano. Então, por favor, quem não respondeu, façam, porque para a gente é de grande valia. Bom. Bom, então eu vou continuar enquanto eles passam recolhendo o questionário. Quero agradecer a presença de todos e eu vou citar aqui os nomes das pessoas que fizeram esse Masterclass acontecer. Obrigada ao Externato Santo Antônio, em nome do professor Antônio. Obrigada ao Colégio Carolina Caçapava de Mello, em nome da professora Fernanda e da Alice. O Colégio Valdomiro Guimarães, com a professora Maria do Carmo da Silva. O Colégio Ideal com o Eduardo, o aluno que dançou ontem, foi muito legal. O Instituto Federal de São Paulo, que veio com os professores Marcelo, a Sorogildo e a Bruna. Obrigada sempre. Ao Colégio Araci, em nome Araci Zebral Teixeira, com a professora Fabiana. Obrigada a Universidade Federal de Itajubá, com os professores Thiago e Luciano, já estiveram aqui, mas os alunos estão aí. Obrigada. O pessoal da Unifesp, do campus de Adema, está com a professora Eliana. Obrigada, Eliana. E esse evento ele foi possível porque a gente teve várias colaborações. Então, os colaboradores externos, em especial as pessoas que estavam aqui na mesa redonda, então eles não estão, mas a gente está gravando e depois passar para eles. Então, agradecer a Sandra, o Marcelo Munhoz, o Ivan Gurgel, a Graciela, e os professores que vão trabalhar hoje à tarde, o Marcelo Porto e a Bruna, que estão ali atrás. Obrigada pela parceria. E o professor Miquia e Cecil, que eles estão chegando com os monitores no período da tarde, o pessoal do Ciência em Show. Eu queria agradecer muito os monitores, todos estão aqui. Cadê os monitores? Tem alguém que pode? Então eu vou esperar o próximo, aí a gente faz Então, esse projeto, ele acontece, a gente começa a escrever há um ano atrás, mais ou menos, e eu tive a colaboração de vários professores do CCNH. Então eu gostaria muito de agradecer o Eduardo Gregórios, que foi fundamental para esse evento, o Gabriel Landi, que está cuidando do café, alguém que trabalha muito e eu acho que ele não está aqui ainda, o Javier, que é um professor que está nos ajudando com a transmissão ao vivo, o Lúcio, que ficou ali no cantinho, mas que a todo instante está de olho no que está acontecendo, que depois a gente vai precisar conversar sobre a questão de ensino, que ele me colocou muito bem. A Maria Beatriz, que estava aqui ontem, eu não sei se ela está por aqui. E o meu amigo Pedro Mercadante, que foi vice-coordenador desse evento, e a gente trabalhou muito, muito, muito. Evidentemente, a UFABC, que deu a oportunidade da gente realizar isso. E a Pró-Reitoria de Extensão, que está aqui, o Rony e a Juliana, muito obrigada pelo apoio, foram fundamentais para que isso acontecesse. E o Pró-Reitor, o Daniel, que não está aí, e o nosso reitor, que mudou a agenda para estar aqui com a gente ontem. Os nossos monitores todos estão agora. Cadê o Pedro? Está aí? Onde está o Pedro? Pedro. Então, nós tivemos a ajuda especial de 2 pós-graduandos. Ângelo, você é fundamental, a gente adora você aqui, venha sempre. Cadê o meu outro? Deixa eu ver se eu acho. Martin, fundamental, muito obrigada pela ajuda. Ele pegou a mochilinha, foi em escola para discutir com vocês antes, para que vocês se sentissem bem. Então foi fundamental o trabalho de vocês, muito obrigada. E aí os monitores que, bom, conviveram comigo esse tempo todo, vocês foram fundamentais. Então eu vou citar um a um. Então, Fernanda, obrigada pelos certificados, muito obrigada mesmo, você ajudou demais. Luiz correu muito obrigada. O Pedro também. O Pedro, acho que vocês viram muito, correndo pra cima e pra baixo. O Diego, que tá aqui quietinho, ele ficou todo o tempo atrás das câmeras e correndo. Muito obrigada. O Vitor, que ficou diretamente no coffee break. Adriano. E o Jason, que ele ajudou a gente antecipadamente, ele ficou doente e não pôde estar aqui. E o Gabriel Landi. Bom, eu vou pedir agora para os professores retirem, a gente vai passar os certificados. Para os professores, vocês distribuam, por favor, não saiam, para a gente tirar uma foto oficial, foto de todo mundo que trabalhou e que esteve aqui. Aí, num segundo momento, a gente vai para o coffee break, certo? E aí depois, foi estranho, né? E depois a gente vai descer, vai para o piso vermelho, que são atividades experimentais de física e o jogo sobre física de partículas. E aí, depois disso, assim, pra gente não ficar se despedindo a todo instante, vocês fiquem à vontade de ir embora na hora que acharem necessário. Odeio despedida, então acho que é um pouco isso. Só queria ouvi-los, eu queria críticas, assim, o que foi ruim e o que foi bom, porque a gente precisa repensar esse evento para o ano que vem. Alguém quer falar?
Seria legal se todos os grupos fizessem assim, sem eventos.
Se todos os grupos?
Fizessem sem eventos.
Se todos os grupos pudessem?
Fazer sem eventos lá da... Mais tempo.
Tá, isso seria mais tempo. Pedro, vai anotando as questões que o ano que vem. Mais eventos. O que mais?
Seria interessante fazer um resumão, assim, pra gente ter, enquanto vai acompanhando, a gente poder fazer anotação, porque no caderno às vezes fica difícil da gente conseguir anotar tudo. Com o resumão, a gente vai fazendo as observações que não tem nele.
Tá. Uma apostila pro dia, na hora que
não
vocês...
precisa ser uma apostila, entendeu? Mas colocar os itens mais importantes, as partículas mais importantes, os conceitos, assim, só pra gente... Tipo, ontem a gente perdeu um tempinho na hora de mexer no simulador, porque a gente ainda não tinha identificado direito como funcionava e tal. Então acho que ajudaria.
Mas a gente recebe material de apoio, vocês todos os escolas receberam, e é uma apostila que vem praticamente tudo que a gente teve resumido. Se vocês querem uma leitura antes de vir para cá, você vai dar pelo básico, muito boa.
Ela está disponível na página da Masterclass, e tem uma página também no Facebook que liga a página do Masterclass. Aliás, essa página está aberta para vocês colocarem as fotos e se marcarem lá. Ontem eu postei todas as fotos, hoje eu estou postando também. Então curtam, isso é fundamental para a gente saber o quanto que vocês gostaram disso e para que a gente possa divulgar esse evento aqui na UFABC. Mais sugestões?
Assim, eu acho que as palestras de início abordaram bastante a criação do evento, não sei o quê. Só que ficou um tempo muito enxuto para a gente abordar o assunto mesmo, que era o LHC, as explicações. Achei que ficou meio confusa a dinâmica. Acho que poderia abordar mais o assunto e menos sobre como desenvolveu esse processo da nossa classe.
Perfeito. Vocês concordam com isso? Que precisava de um tempo maior para estudar física de partículas? Vocês não ficariam cansados? Claro. Precisa que eu estou te ouvindo.
Tem algum site que vocês disponibilizam os slides que vocês passaram?
a gente está colocando, se você entra no nosso site do Masterclass, que está na ficha aí de eventos, UFABC, sabe? No home, se você clicar ali, tem arquivos. Então tem a palestra do professor Pedro Mercadante, e eu vou colocar os outros lá. Tudo o que a gente... pelo site, tá bom? Mais alguma coisa? Tá. Tem uma coisa que não me incomoda, mas que eu fico preocupada, que é o momento da interação em inglês. Dessa vez eu acho que os pesquisadores eles falaram rápido, mas no geral a gente costuma ter um pesquisador dos que eu já participei, alguém que fala espanhol ou português. Então, eu não sei se tudo bem, o que vocês têm a dizer a respeito disso.
Na verdade, aquela menina, a Maria, ela não era americana mesmo, né? Porque o sotaque dela era totalmente...
Ela é espanhola.
Eu imaginei.
Ela é espanhola e fala rapidíssimo, ninguém entende.
Acaba bem difícil de entender ela. É mais...
Ela não deve mais entender nem espanhol.
Gisele, realmente a Maria falava muito rápido, difícil de entender. Não existe a possibilidade de ter um tradutor presente, enfim, tradutor propriamente, um intérprete para poder fazer essa tradução para os alunos?
Isso pode... A gente anota e vê o ano que vem.
Pergunta, vocês acham que vale a pena? Porque o intérprete atrapalha, né?
Eu acho que é complicado porque pode ter de vários países. Aí teria que ter um de francês, um de...
O problema é que como é que funciona o intérprete, tá? Os únicos lugares que funcionam direito se você tiver o seu ouvidinho direto aqui, e aí você vai ouvir só a voz do intérprete. E isso é muito custoso, isso não dá para implementar. O que dá é para eu ficar traduzindo. Eu acho que um intérprete não faria melhor que eu, ficar traduzindo aos poucos, mas atrapalha, tá? Não, o intérprete desses que você ouve direto, claro que aí tem que ser um profissional, não dá para ser eu. Mas se for para traduzir enquanto o cara está falando aos poucos, aí eu acho que um intérprete não faria melhor trabalho do que eu. Não tem... o cara falou alguma coisa aí, você resumiu o que ele falar...
Mais algum comentário?
Oi, ouvi.
Enquanto as pessoas estão falando, podia tentar colocar alguém assim pra colocar uma legenda, tentar colocar enquanto estão falando. Pode ser, se não for tão complicado, se não der trabalho, podiam colocar uma legenda pra gente tentar entender o que estão falando, assim, com uma legenda embaixo.
A gente vai anotar essas observações, que isso também pode ser custoso. Um projeto talvez a gente coloque e a gente... Mas pensaria.
É que é ao vivo, não dá para entender.
Então, é por isso que eu estou falando. Se não for uma coisa de trabalho, então você colocar.
Uma das coisas, não dá para mudar a dinâmica deles, tá? Eles não vão fazer a 10 minutos. A ideia é que todo mundo vá aprender uma linguagem comum de comunicação e é o inglês, tá? E faz parte, tá? Dá pra gente fazer aqui internamente, só que daí a gente vai perder enquanto eles estão falando. E tem uma questão que é difícil mesmo acompanhar, mesmo que fosse em português, porque a pessoa fala rápido, o som tá ruim, a pergunta... Então, são coisas que a gente encontra no dia a dia também, tá? Nas nossas videoconferências, a gente tem que aprender a entender só o essencial.
Mais algum?
O que eu também acho que tinha que ter é um pouco desse teste de qualidade com todo mundo junto antes. Porque às vezes não é só o foco que está ruim, os outros também, a qualidade chamada dos outros estavam péssimas e acaba interferindo a qualidade de todos juntos.
Então,
total.
Eu confesso que a gente fez esse teste.
Ah, não, a gente estava até presente. O problema são os outros também. Os outros entraram em cima da hora, entram exatamente no horário e acaba não fez até semanas anteriores.
Na verdade, todos são obrigados a fazer o teste semana anterior. Tem lá uma semana que o CERN coloca para todo mundo fazer o teste com o equipamento que vai usar. Só que todos os institutos têm os problemas que a gente tem aqui também. O equipamento não fica aqui parado, guardando, esperando. Aí quando chega, funcionou, mas agora não funciona. Mas isso é uma coisa que a gente pode anotar para eles, sim. E eles estão sempre tendo esse feedback.
Eu acho interessante, então, quando vocês forem fazer o feedback do evento, comentar o que foi mencionado aqui sobre os palestrantes. Não sei se precisa de microfone. Então, quando for fazer o feedback para o CERN, para recomendar os palestrantes, quando eles forem falar ano que vem, que eles diminuam, sabendo dos problemas técnicos de todos os países que estão participando, que falem um pouco mais devagar, ou até mesmo tentem entender um pouco que são falantes de outra língua, nem todos falam o inglês, e mesmo assim os problemas técnicos sempre vão ocorrer, não importa se é no Brasil, se é na França ou em Madrid.
Aqui, Vitória. Aqui, depois a
Eu acho mais apropriada a ideia que o Pedro falou, porque enquanto eles falam, eles dão tempo para que os outros países se manifestem. Então, por exemplo, eles não ficam falando muito tempo a mesma coisa. Dá para dar uma resumida e alguém poderia ficar traduzindo do lado o que eles falam, já que o nosso microfone fica desligado. E quando for outro país, der para entender, traduz também. E quando passar para o nosso, também dá para traduzir. Tem essa espera assim, para responder, eu acho que dá para traduzir.
Bom, eu gostaria de ressaltar uma coisa que eu achei muito positiva, que foi a visita do Martin à escola. Eu achei aquilo fantástico. Então eu acredito que os meus alunos, quando chegaram, eles já não tinham tantas dúvidas na hora das palestras, porque foi assim algo muito esclarecedor. Eu acredito que todos eles concordam, porque eu achei assim show. Isso eu gostei bastante, uma coisa que deve permanecer.
Obrigada. Acho que isso foi um aprendizado do ano passado para cá. A gente sentiu que precisava ir para a escola e aí uma arte se propôs. Fico feliz que deu certo. Mais alguma? Alguém está com o microfone?
Aqui,
Em relação ao que a professora falou, realmente ajudou muito o Martin ter ido lá, nos instruiu. Realmente melhorou muito, porque senão nós teríamos chegado aqui completamente perdidos. Porque em algumas escolas nós estamos tendo problemas com os professores de física. Então, nós não estávamos realmente... Não, mas estava crítica a situação. Mas com a ajuda deles nós não ficamos tão perdidos. E também queria saber se... tudo bem que já fica difícil, mas se podia prolongar um pouquinho mais a questão dos dias. Porque assim, é muita coisa para aprender em tão pouco tempo. Realmente, é muito pouco tempo, mas pelo que eu vejo aqui, o pessoal está realmente interessado. Então eu acho que quem está interessado, quem está se esforçando, também merece isso. Porque estão buscando.
Então, físicos de plantão.
Posso falar? A escola podia tentar abrir para aulas disso um pouco antes do evento.
Sim. Então, a gente tem uma proposta para os próximos anos, não sei se a gente consegue implementar, é que talvez a gente faça cursos que antecipem isso, porque aumentar os dias do evento fica muito complicado, porque, enfim, a gente está no meio do quadrimestre e, assim, para a gente é muito oneroso. Mas é provável que a gente faça oficinas sobre o assunto. Então, talvez nesse sentido ajude. Mas ainda são ideias.
Talvez também após, né? Em vez de só preparar, como você mesmo diz, o evento motiva e cria dúvidas. Então fazer algo após o evento. Mas cabe também às escolas. O nosso ideal seria, claro que para o professor é muito complicado, mas a gente daria apoio a professores e grupos de alunos que buscassem esse aprofundamento, tá? Mas não precisa ser com todo mundo, porque é para quem foi pego mesmo, né?
Só uma pergunta, se a gente oferecesse esses cursos no final do ano, vocês viriam? Sim. Pessoal, bom, nas férias. Sim. Estudar física nas férias. Sim. Vou pensar com mais carinho a respeito desses cursos. Só, a gente precisa encerrar, então, porque daqui a pouquinho a gente precisa só vou mostrar para vocês a página. Eu achei que vocês já tinham entrado, mas de qualquer forma, é Masterclass UFABC, e aqui, né, os arquivos eu vou colocar. Então, os arquivos a gente coloca aqui, International, bom, aí vocês clicam aqui, estão alguns arquivos. O material de apoio ao professor participante, está aqui, tá? Você estava perguntando. Orientações gerais para os laboratórios e a apresentação do professor Pedro. Eu vou colocar as outras, isso, a gente vai disponibilizar o quanto antes. Aí vocês olhem, tem várias coisas aqui, as instituições participantes, todos vocês estão postos aqui. E aí tem o Facebook, que eu já coloquei, já postei, vocês já estão na rede, tá? Então entram, curtam, e está aberto para que vocês postem as imagens que vocês pegaram no evento. Agora, tudo bem? Alguma dúvida? Entrem. Tá, então, os certificados eles estão com os professores. Eu vou pedir para que vocês se juntem para a gente poder tirar a foto. E aí a gente sobe para o 7º andar, para o coffee break. E depois a gente desce para o piso vermelho, onde estão ocorrendo as atividades. Gostaria muito que vocês participassem de todas as atividades, certo?